Hello, good evening, and welcome to this very popular intervention session on normal distributions and skewed distributions. So popular that there's nobody here with me. So I don't want to waste an opportunity. So what I will do is do a session on normal and skewed distributions. Obviously, I won't have anybody to interact with. So I'm going to have to hope I'm going at the right pace for you and kind of addressing the right things about this. It'd be really helpful if you do end up watching this at a later date, if you could just drop me a message to let me know whether it helped or not, or whether you need more help, or there's other questions I need to answer in a separate session. But yeah, feedback would be really useful, because obviously I'm not going to be able to get that at the end of the session directly from you. So I'm going to try and get myself set up so you can see a whiteboard. Just bear with me a minute. Okay. Now, hopefully this will get rid of the glare problem that we had last time we did this as well. So let's start with a normal distribution. Okay, and it's always on an axis like this, okay, where you have frequency on the y-axis. Okay, so this always measures how frequent something is. And here you always have some kind of scale, okay? So I'll keep this simple, okay? And let's suggest that on this particular occasion, it's a happiness scale. And so I've asked a group of people to tell me how happy they feel on a scale of 0 up to 10. Okay, I'm not going to write all the numbers in, but you can imagine that goes from 0 to 1, 2, 3, all the way through to 10. Now, I suspect if I actually did this as a survey, it would give me a normal distribution. By that, I mean that 0, okay, people not being happy at all, would probably be quite rare, okay, perhaps a small number of people. And similarly, 10, extreme happiness, okay, no concerns at all, would also be quite rare. I'm guessing that most people, on an average day, would score themselves as being somewhere in the middle. And that would be a 5. Okay, so here I'm saying that 5 would be a very common score or a very frequent score. Then obviously what you get for the other scores is something like this. Okay. So when you move to 1, that's more common. Okay. People score themselves 2 is more common again. And so you get this pattern, which if I draw it more as a curve, is what we call a normal distribution. Okay, sometimes it's called the bell curve, okay, but in your exam, it will be called a normal distribution. I think I've said before, if it looks like any letter, it looks like the letter N. Okay, that might help you remember it's called a normal distribution. And it's a symmetrical distribution. It doesn't have to be exactly symmetrical, but what you should see is that the frequency of a score increases, but when you get to the middle of the scale, it begins to decrease. So if the scale, for instance, was 1 to 100, you might still see a similar pattern. So that could be people's percentage score on a maths test, let's say. So most people get 50%. Very few people get that 100%, everything right. But equally, very few people get 0 or nothing on the test. Okay, so whenever you see this pattern, okay, it might look flatter than that. Okay, it might look more peaky than that. Okay, but whenever you see that pattern, that bell curve, that symmetrical bell curve, that is a normal distribution. And what it basically means is when you measure people on a scale, as we do often in psychology, you'd expect the most common score, the most frequent score, to be the middle score. And as you go down the scale or up the scale, the scores become less frequent. So I've described what a normal distribution is there. You've also got an example of a normal distribution. Let's stay with this example. So it's not a happiness scale anymore. Then I've turned this into maths scores, didn't I? Maths test scores. Okay. And the other thing you need to know is where the mode and the median and the mean would be on this normal distribution. Well, the mode is quite easy because we can see that 50 is the most frequent score. Okay, most people score 50. So the mode, just bear with me, is 50. Okay. The median is the middle score. So if you imagine, if you lined up all the zeros, not many of them, and the ones, and the twos, and the threes, and the fours, okay, so it's gone for a long time. If you lined up all those scores, okay, and kept going up to 49, lots of 49s, lots of 50s, 51s, 52s, if you imagine all those different scores lined up, the middle score would be 50, okay? Well, imagine those happiness scores, okay? A 1, a couple of 2s, a few more 3s, and so on, okay? If you imagine that, okay, if you keep going with that, then eventually 5 would be in the middle, because then you get 6s and 7s and so on, okay? So the median is also in the middle. You can probably guess, or you might remember, where the mean is. On a normal distribution, the mean is also in the middle, because if you added up all those 1s and 2s and 3s, if it was a 10, if it was a scale of 10, you added up all those scores, okay, and divided them by the number of scores, you would come back to 5 on this example. On this example here, you'd come back to 50. So remember, this is a normal distribution. Okay, call that a normal distribution. And so whenever you have a normal distribution, the mean, the median, and the mode will always be the same score. Okay, the score that's in the middle. So in this case, it's 50. On my previous example, when it was happiness scores, I'll just do a happy face this time. When it was happiness scores, then 5 was the middle score. So 5 would be the mode, the median, and the mean. Let's do one more example to make sure you're clear on that. 0 to 24, we'd expect 12 to be the mode. It would also be the median, okay, the middle of all the 0s and 1s and 2s and 12s and 13s up to 24s. If you line them, all up, okay, 12 would be in the middle. And if you added all those scores together and divided by the total number of scores, that would also bring you back to 12. Okay, so 3 things you need to know about the normal distribution: what it looks like so you can recognize it, what it's showing you. Remember, that's showing you that the middle scores are the most common, the most frequent, the extreme scores are the least frequent. And on a normal distribution, you find the mean, the median, and the mode in the middle of the scale. Okay, I almost said any questions, but there's nobody to ask me any questions. So just bear with me while I clear the board. There you go. As if by magic, okay, the board is clear. Across a bit, sorry, right. Okay, so skewed distributions, okay. Well, if you have a skewed distribution, okay, we're still using the same axes, okay, so you've got frequency, the y-axis, and then some kind of scoring system, doesn't matter what it is, on the x-axis. And rather than there being a perfect symmetrical normal distribution, instead it kind of skews, for instance, that way. Okay, so if this was a maths test, this would be good news, wouldn't it? Because if 50 is there, for instance, okay, then you've got quite a lot of people, I don't know, it looks like quite a lot of people are getting 75, okay, and very few people or students are doing badly in this test, okay. So the distribution is skewed, okay. It's a skewed distribution and it's skewed towards the higher end, okay. Now, although we talk about that being where the skew is, okay, just to confuse things, you need to talk about where the tail is going, okay. And the tail is essentially going in a negative direction, okay. So this is called a negative skew, okay, because of the direction that the tail is going in, okay. It's a negative skew. And that makes sense because although we think about the results being skewed that way, what's actually pulling them, what's actually skewing them, are the scores down the bottom here. Otherwise, it could look like this, couldn't it? Okay, so if it was a normal distribution, it would look like that. Okay, all those students doing really well. Okay, the lowest score 45. Okay, but it doesn't look like that. Okay, it's not a normal distribution. It's not a bell shape. It's actually skewed towards the negative end. So that's why we call it a negative skew. Okay, so it doesn't skew this way. It kind of bubbles that way, if you like. So if you see this in an exam, you need to be able to know that that's a skewed distribution, or better still, or perhaps the marks will rely on it, you'll need to be able to say that it's a negative skew. What does this mean for the mode, the mean, and the median? Well, the mode is still the most frequent. Okay, so the most common score in this class is 75. What about the median score? The median score is going to be somewhere in the, it's going to be in the middle, and it'll be somewhere around here. Okay, because there are quite a lot of scores this side, spread out, if you like, and about the same number of scores this side, but more bunched together. So we'd expect the median, okay, to be closer to the middle. Perhaps not 50 this time, but definitely closer to the normal middle. And what about the mean? We'd expect the mean to be even lower again, perhaps 55, because the mean is being skewed by some very, very low scores. So you've got these students doing really well. The fact that one or two have got really low scores will pull down the mean. Okay, so those students that have got 5s and 10s, okay, they're going to pull down the mean. So on a negative skew, you'll see the mode being higher than the median, and the median would normally be higher than the mean. So on a negative skew, rather than being together, the mode, median, and mean will occur in different places. As well as a positive skew, so as well as a negative skew, beg your pardon, there's also the possibility of a positive skew. So I won't do this by magic this time. Okay, it's simple. Let's sort the board out. Okay. So again, let's imagine these are results from a maths test. Okay. So this is my group. Okay, I haven't got that nice normal distribution. Okay, like you might expect to get. I haven't got that negative distribution that we saw last time. What I've got is this positive skew, although it's not particularly positive in this case. Okay, remember the skew is where the tail is going, so it's going in the positive direction. Sorry, the tail is going in a positive direction, but it's bubbling towards the lower end. So it could be worse. Okay, my class could follow normal distribution, so nobody's doing better than 60, but at least there's a few students, they're not very frequent, okay, but there's a few students that are doing really well at the top end. Okay, so this person here getting 95 might be one of those. So hopefully you can work out what this means for the mode, median and mean this time. The mode is down here now, okay, about there, sorry, the most frequent score, okay, it peaks here. So it's not particularly good, okay, it looks like it might be round about 28, 29, okay, that's the most common score in this class. Will the median be a little bit higher, I think, okay, because about half the scores seem to be here on this, so draw a line there. Okay, about half the scores seem to be that way and the other half that way. So this score would be somewhere in the middle. So that looks like a 45. That's a bit more encouraging. Okay, so the median isn't at the peak necessarily. Okay, it's in the middle. And although this class haven't done particularly well, thankfully, there are a few good students, okay, at this end that have got really good scores. So that will pull the mean up, okay? It will skew it upwards. So for instance, the mean might be just over 50. So although a lot of students did badly, most students got 26, 27, the high scores are pulling it up. And so again, if you see this shape of distribution, you should know it's a skewed distribution. And you should be able to say that it's a positive skew because you're seeing where the tail goes. And again, this kind of skew distribution separates the mode from the median to the mean, but it's the opposite way around now to the negative skew. The mean will be higher than the others, the median will be higher than the mode, and the mode will be the lowest measure of central tendency on this kind of distribution. So for the positive and the negative skew, you should know what they look like. You should be able to recognize them. You should be able to describe what they show. So the positive skew, for instance, shows that most people are scoring low, but there are some outliers that score very high. And you also need to know where the mode, median, and mean would sit approximately on a skewed distribution. So that's my recap, my going back over normal distributions and positive distributions, and positive skewed distributions and negative skewed distributions. And if you understand that, if that makes sense, that's all you need to know as you go into any exam. I won't say thank you for being here, but hopefully some of you will take the time to watch this, and I'll say in advance thank you for any feedback you can give on whether it's helped you understand it better or not. Thank you.